Hey guys, welcome back to SciPi Academy, and today we will be discussing, for now, our last topic regarding quadratics. Obviously, this is such a vast topic that we're going to return to it in the future, but for now, this is it. So, today I'm going to be discussing the discriminant, and this is incredibly useful. I want you to forget about the quadratic formula I have over here for a moment, and think about a number. Okay, any real number, and if you square it, the result is greater than or equal to 0, always. Okay, this means that if y is negative in this case, okay, if this means that the square root of y, if y is negative, it cannot be a real number. Okay, obviously it can be an imaginary number, but that is something for a later date. But the square root of negative y in this case, it won't exist. Okay, because there's no such number that if you square it, it comes out to be a negative. Now I want you to come to this. Okay, I want you to focus for this video on this part of the quadratic equation. By looking at this part, we can say a couple of things. We know that the square root of b squared minus 4ac, it cannot be equal to 0 for there to be a real answer, for there to be a real root. Okay, to have remember, like I said last time in the previous video, which is now over here at the top, the roots are basically answers of quadratic expressions. Okay, for this to have a root, to have any answer, it cannot be less than 0. Okay, because if that's less than 0, which basically means it's negative, it doesn't exist. So now, from this, we can derive 3 roots, okay? Forget about the square, but if b squared minus 4ac is less than 0, okay, that means that it has no real roots, okay? Because that means it's negative, and it can't be negative, all right? Second rule, if b squared minus 4ac is equal to 0, it has one repeated root. Now you might be thinking, what's a repeated root? I promise I'm getting there. Bear with me. Okay, and the last rule that we need to know is b squared minus 4ac is greater than 0. This means that it has 2 distinct real roots. Okay, 2 roots that are different to each other. Now, something that I really believe in, illustrating maths concepts. So, let's go on to it and I'll show you the graphs of this. Okay, so I have 6 axes over here. Okay, 6 different. And following on from last time, what I'm going to do is I'm going to make this one for a greater than 0 and this one a less than 0. Now this will obviously have different effects. It'll cause the shape of the graph to change from either a smiley face or a sad face. Again, there's a link up here. Go onto it and you'll know exactly what I'm talking about. So, if b squared minus 4ac is greater than 0, this will have 2 distinct real roots. Okay? 2 real roots. For this one, the graph will look like this. Again, from the last video of quadratic graphs, you know that these 2 are roots. Wherever the graph crosses the x-axis means there's a root, means there's an answer, means there's a value of x that's there to find. Okay? So that's why when you graph these quadratic equations, you get different graphs. Moving on to the second one, this is when b squared minus 4ac is equal to 0. Remember I said one repeated root? Well, I'm about to demonstrate to you what I mean by one repeated root. This means that the graph literally touches it and goes. Okay? Now, if we were to find from the last video again, the turning point of this right here, that would lead us to the root. Okay, we can either find the one repeated root or we can complete the square and find the turning point right over here. The last and final graph for this would be this. Obviously, that means that b squared minus 4ac is less than 0. Okay, it has no real roots. Looking at these graphs, you get a real understanding of what roots actually are. If the quadratic equation for this graph would intercept the x-axis twice because there's 2 correct answers for it. This, there would only be one answer. This, there would be no real answers. And then you would have iota, the imaginary value of square root of a negative number. Okay? But that is for a later date, and I don't want to confuse you right now. Moving on again to the negative values, the sad graphs. This one would be like this, right? Again, 2 real roots. Over here, we'd have something that would look like this, 1 real root, and this one wouldn't even touch the axis at all. Okay? So we understand how important the discriminant is, because just by looking at the discriminant, we can see what the shape of the graph would be like. Let me demonstrate further. Okay, so we have this quadratic equation right here, and we want to find out how many answers does it have. Before we try solving it, before we go on about it, we want to know how many roots does it have. Well, it's simple. Remember the formula? Remember the a, b, and c's, and you need b squared minus 4ac. Remember, if this is greater than 0, it means something, less than 0 means something else, and equal to 0 means something altogether. Looking at this, we can just substitute in. We get negative 2 squared minus 4 times 1 times c, which is negative 15. Okay, negative 2 squared is 4 minus negative 4 times negative 15 is 60 times 1 is 60 again, so plus 60, and we can say that this is 64, right? 64 is obviously greater than 0, which means that b squared minus 4ac is greater than 0, and thus we know that the graph of this will have 2 distinct roots. Obviously, I'm not sketching it perfectly here, but whatever it is, whatever shape it is, wherever it is, it will cross the graph, it will cross the x-axis twice. And we also know that when we solve this quadratic equation, we should get 2 different answers. If we don't, we've done something wrong. So that's where the discriminant is super useful. And I hope this video has been really helpful for you guys. Thank you so much guys for watching. This was the last video in our quadratic video series. If you guys want me to discuss some other topics, maybe you're struggling with it, or maybe you just enjoy it a lot and you want to see me explain it further, leave it down in the comments and we'll definitely get on it. Thank you so much guys for watching. Bye bye.